Dear students, I start with lecture 23 of 101 and 102. Have a look on the sum which was already started in the previous sum. આગળથી આપણે જે શરૂઆત કરી છે એકવાર જોઈ લો. Sigma n is running from 2 to infinity square root of n raised to 4 plus 1 n raised to 4 minus 1. એટલે an આવું થશે. પછી એની અનુબદ્ધ કર્મીથી આપણે ભાગાકાર અને ગુણાકાર. Sir, a minus b, a plus b means a square minus b square. So this will be n raised to 4 cancel થશે તો 2 upon r થશે. Say bn equal to 1 upon n square. Therefore sigma bn is convergent as value of b is equal to 2 અને હવે આપણે આગળ જઈએ. Therefore limit n tends to infinity en upon bn equal to, obviously practical comparison test उपयोग કરીશું. Limit n tends to infinity 1 upon square root of n raised to 4 plus 1 plus n raised to 4 minus 1 upon 1 upon n square. En and bn ની કિંમત લખી છે, સાદું રૂપ કરીએ. We simplified and therefore this is equal to limit n tends to infinity n square on square root of n raised to 4 plus 1 n raised to 4 minus 1. So this is equal to limit n tends to infinity. It was 2 upon 2 is outside n square एक्चुअली આપણે સ્ક્વેર રૂટ માંથી n રેઝ ટુ 4 બહાર લીધા છે પણ બહાર તો n સ્ક્વેર જ આવશે કારણ કે સ્ક્વેર રૂટ છે. So n square will be cancelled and therefore this is equal to 1 upon square root of 1 plus 0 1 minus 0. So it is 2 upon 1 plus 1. So answer is 2 or 1 and which is not equal to 0. Therefore, by practical comparison test, sigma bn is convergent implies sigma an is convergent. So this is answer. one more sum on the board. In this sum, we are going to use this fact equation. Answer here. An equal to minus n. So obviously we multiplied and divided by this term, means it is and we divide by the set n square. જો આ x છે y ની કિંમત n લીધી છે એટલે x² + xy + y². એનાથી ગુણ્યા છે એનાથી ભાગ્યા છે. ચેક કરી. So this is equal to an equal to n cube plus 1 cube 1 by 3 minus n cube upon n square plus 1 2 by 3 plus n 1 by 3 plus n square, and therefore this is equal to n cube will be cancelled, so it is 1 upon n cube plus 1 2 by 3 plus n cube plus 1 1 by 3 plus n square. तो आ an છે. Now we choose dn equal to 1 upon n square. Therefore, sigma bn is sigma 1 upon n square is convergent as value of p is 2. Therefore, limit n tends to infinity an upon bn. Obviously, we are going to use practical comparison test, and by that we put the values of an and bn. 1 upon n cube plus 1 2 by 3 n cube plus 1 1 by 3 plus n square upon 1 upon n square. Now simplify it. કરી શકો તો તમે આગળ ગણતરી કરો. This is equal to limit n tends to infinity n square n cube plus 1 2 by 3 plus n cube plus 1 1 by 3 plus n square. છેદમાંથી n square કોમન લઈ શકાશે થ્રુ આઉટ. limit n tends to infinity n square આમાંથી n cube બહાર નીકળશે પણ બહાર તો n square જ આવશે. 1 plus 1 upon n cube 2 by 3 1 plus 1 upon n cube 1 by 3 plus 1. So this is equal to n square will be cancelled. So it is 1 upon 1 plus 0 2 by 3 1 plus 0 1 by 3 plus 1. So this is 1 by 3 not equal to 0. Therefore by practical comparison test sigma Bn is convergent implies sigma An is convergent, and that's the end of this sum. So look it. One more sum on the board. 1 by 2 1 by 2 raised to 1 by 2 1 by 2 raised to 1 by 3 1 by 2 raised to 1 by 4 and other terms. હવે મેં તમને જે કહ્યું છે ને 38 થી 53 જેટલા પણ થિયરમ છે એમાંથી કયો ઉપયોગ થઈ શકે એવો છે કે જે આને કન્વર્જન્ટ છે કે ડાયવર્જન્ટ છે એવું નક્કી કરી શકે. સો ચેક ધેટ ફ્રોમ થિયોરમ્સ portion 38 to 53 which one will be used to prove it is convergent or divergent. Check that. Here we are going to use number 44. 44. Read the statement. એમાં એવું છે કે sigma an with positive terms is convergent then nth term tends to 0. હવે આમાં તમે જુઓ, so we start to prove it. Answer, here an equal to 1 upon 2 raised to 1 upon n. Therefore, limit n tends to infinity, an is limit n tends to infinity 2 raised to 1 upon n. So this is equal to 1 upon 2 raised to 0, 1 upon 1, and therefore it is equal to 1, which is not 0. And therefore by this theorem, is divergent. બરાબર સમજીને કરજો, આના ઉપરથી આપણે કર્યું છે. I will take one more sum of the same type, but after this sum. તો પહેલા તમે આ બરાબર જોઈ લો. જો આમાં n ઉપર ટેન્ડ્સ ટુ 0 હોત તો આપણે કન્વર્જન્ટ છે કે નહીં એ નક્કી ના કરી શક્યા હોત, પણ કન્વર્જન્ટ હોય તો એ 0 તરફ જશે. If the series is convergent, then nth term tends to 0. But if nth term tends to 0, did not be allow us, it is convergent. But as it is not 0, it is confirmed that it is not convergent. One more sum on the board, sigma 1 square root of n upon 1 plus n. Answer, here n equal to square root of n upon 1 plus n. Therefore, limit n tends to infinity, n is limit n tends to infinity square root of n upon 1 plus n. આપણે એક થિયરમ ઉપયોગ કરીશું અત્યારે, પણ એ તમારે જાતે નક્કી કરવું પડે કે 38 થી 53 માં કયું આમાં વર્ક કરી શકે એવું છે. ક્લિયર? limit n tends to infinity and n will be cancelled, so this is equal to square root of 1 plus 0, and therefore this is equal to 1, and obviously this is not equal to 0, therefore it's divergent. By theorem 44. One more sum on the board. 2 by 3 plus 1 by 3 plus 1 by 6 plus 1 by 12 is equal to sigma a. તો તમારે શું છે કે એકવાર આને જોઈને નક્કી કરવું પડે કે ભાઈ આ કઈ રીતે થશે. આન્સર, here a equal to, જો આને 2 થી ડિવાઈડ કરો તો અહીંયા, આને 2 થી ડિવાઈડ કરો તો અહીંયા, આને 2 થી ડિવાઈડ કરો તો અહીંયા, એટલે આ સમગુણોત્તર શ્રેણી છે. It's a geometric progression, and therefore sigma a, this is obviously less than 1, is a plus ar square. So this is equal to A upon 1 minus r. So this is equal to 2 by 3. This is the answer, and therefore so it's not a sum of your type, but it may be in exam for 1 mark. So I will stop this lecture here. See you in the next lecture. Thank you very much.